what I'm thinking is if we could measure how far away the staircase is, the staircase is from the windmill, which we can do it based on tiles, how far we can walk in a second, like speed, whatever is the easy way to do what I'm thinking.
So Paul pretty much called me out and demanded I figure out the distance from the staircase here to the windmill here. This is demonstrably simple, but what isn't easy is the second part of the demand, which is to convert that to actual feet. Now, I know he's not actually asking me to measure it. Canonically, he's talking to his friend. Also, canonically, this was recorded back in 2017, before I started measuring the grids, or as he calls them, tiles, like the amateur he is. So thank Paul for coming up with the idea, everyone, a year before I did it. It's like a beautiful mind, but instead of John Nash, it's someone even better. Anyway, let's first start by making a universal tile measurement. We do this by finding scenes in which the floor can be measured, and where Paul and the camera are positioned in the same places. As in, Paul is around the same distance away from the camera, and the camera is around the same height and elevation in all shots. Then, we transpose the grid to the above Newmaker plane. While not helpful mathematically, as we will be measuring Paul's steps to determine the distance travelled, this helps us so we can get an idea as to how far Paul has travelled and how big a tile is in real life later. Now we measure how many steps it takes Paul to reach the camera from the stairs and the windmill from the camera. This gives us a right-hand triangle to work with. Now we just need to get the hypotenuse for the triangle, and that'll be our total grids from the windmill to the stairs. So, counting the steps, which we know to be 1.2 grids per step, we see that Paul takes about 27 to 28 steps to reach the camera from just outside the stairs, 2 grids away specifically. Using the median of the steps, Paul takes 27.5 steps at 1.2 grids per step, plus the 2 grids to the left of the stairs where he started from. That gives us 35 grids traversed. From the camera, Paul takes 20 steps to reach the windmill. 20 times 1.2 is 24, so that's 24 grids traversed. Now we have our A and B. To get the hypotenuse, we use Pythagoras' theorem, which is a squared plus b squared equals c squared. This gives us our final grid measurement, which is from the bottom left of the stairs to the bottom center of the windmill, which is this. Rounded, it's 42.5 grids. Now, to measure the tiles in real life. To do this, we'll need to find an object in Petscop that actually also exists. Luckily, there is one in the house garage, an old CRT computer monitor. These things were pretty much uniform, with a 4:3 resolution and pretty much similar dimensions. Here's one I found online that has the dimensions 6.1 inches by 17.7 inches by 6.3 inches, in terms of width, diameter and height. So I'll use this as a stand-in for the current monitor. Now, it'll be impossible to find the exact measurements of a tile with the information we have, but we can get close. Now, we don't need the height or diameter of this computer, just the width. These grids are uniform squares. We know that the height is the same as the width. So what we do now is we carefully place the objects on a map like so, using the grids to make it as accurate as possible. This can be a bit messy as we're measuring by eye, but we have to be careful. Once I was satisfied with the placing and size of the objects, we need to place a line for the monitor's width, which we know is 16.1 inches canonically. Then we place it on a grid and measure how much we need to extend it for it to be as long as one grid tile. I had to extend the line 50% of its current width to be as long as a grid segment. 16.1 times 1.5 is 24.15 inches. So from these measurements, though prone to being inaccurate to a degree, we can see that each grid is, in real life, 24.15 inches up and across and has a total surface area of 591.675 inches. In terms of how far the stairs are away from the windmill in real life, we need to times 24.15 by 42.5, which gives us 1026.375 inches. That's 26.1 meters or 85.5 feet rounded. I thought, well, that's a little bit short. It looks like he runs further than that in the game. But no, I measured 26 meters in my driveway and walked it at a normal pace, and yeah, it took me about as many steps to go that distance and traverse as many grids as it would Paul in the game. So there you are, Paul, there are your measurements. Happy grave robbing or whatever. Wait, Paul said this back in 2017, but this was uploaded in 2019. It's not like he's asking for it now. Also, he hasn't had control over the channel for some time. The family or someone else does. When he controlled it, the descriptions weren't so cryptic, so he doesn't have it now. Wait, did I just help some guy find something that was meant to be hidden?
Oh crap.